Okay, continuing on. Number 8, all the different kinds of alcohols have one OH functional group. If they have 2 or 3, they are called glycols or something else. But for an alcohol, it only has one OH functional group. Okay, some of you messed up on that one. The next one, number 9, building blocks of all proteins are alpha amino acids. That's C. Polyunsaturated oils that have a higher number of units with double bonds. That's the answer there, B, 10B. Continuing on for number 11, hydrocarbons with double bonds are alkenes, E. Single bonds are A, double bonds are E, triple bonds are Y, and this doesn't. We don't have those for hydrocarbons. Synthetic polymers that are variations of ethylene-based monomers are manufactured from fossil fuels. Okay, oxidation of ethanol produces acetic acid. And then the chemical reaction that usually takes place on an organic compound is at the site of any of the above is correct. A double bond, a lone pair of electrons, a functional group, any one of those is where you can design an experiment so that that's where the reaction takes place. R and the ROH is a hydrocarbon group ending in YL, like a methyl, ethyl, propyl, whatever, right? That's what that means. Okay, so the answer there was B. 16. Bottle of wine that has gone bad now contains acetic acid, C, CH3COOH, acetic acid. Liquid oils from the plants may be converted to solids by adding hydrogen to those double bonds. So the answer to 17 is D. Number 18. Aromatic hydrocarbons are often used as solvents. Organic acid found in sour milk and in your muscles as a product of carbohydrate metabolism is lactic acid. And then we'll continuing on. We have what is the organic compound used in perfumes? The good smells are the esters. Remember, the good smells are esters. Sugar, starches, cellulose belong to which group? They're carbohydrates. Fractional distillation separates different fractions by differences in their boiling point. And the proof is twice the percent, right? So a 5% would be 10 proof. Okay, continuing on then, we get into the radioactivity. The property of radioactivity in material is caused by instability from struggles between electromagnetic and nuclear forces. Radiation from radioactive material can be any of the following except it's not a proton. It is not a proton. Helium nucleus, electron, gamma ray, but not a proton. A beta particle, sometimes called a beta ray, is an electron from the nucleus. Okay. And then number 4, the answer is C. After joining with subatomic particles, it finds itself in a child's balloon. It's an alpha particle, right? That's the helium one. Most like beta particle, that's an electron. It joins of its kind in making the thunder and lightning. Yes. Electrical discharges. Nucleus emits a beta particle, so the number of nucleons it contains is now the same. Okay. This is not a nucleus emits an alpha particle, so the nucleons it contains now are less. Mass of an atomic nucleus compared to the mass of the individual is always less. Enriched uranium now has more uranium-235. That's what you enriched. That uranium-235 is what undergoes the radioactive decay. The maximum binding energy per nucleon occurs in the nucleus of intermediate molecular mass, not too low, not too high. The low ones combine for fusion, the high mass break apart under fission. Radiation from the source in your everyday life is called background radiation. And the measure of the radiation that takes into account the alpha, beta, and gamma are the REMs, REMs. Activity of a radioactive material is measured in units of the Curie, A. The control rods made of special materials that absorb neutrons. That's what their job is. They absorb neutrons and stop that chain reaction from continuing on. 15. The ejection of a beta particle from the nucleus results in an increase in the atomic number by 1. The ejection of an alpha particle from the nucleus results in a decrease in the atomic number by 2. The ejection of a gamma ray from the nucleus results in none of the above. It doesn't change the atomic mass or the atomic number. All of the naturally occurring radioactive decay series and the radioactive elements have decayed to lead. Lead is what they finally end up as. Okay? And then I want to talk a little bit about some of the lab reports that you've submitted. This is lab report number 10. Many of you use the accompanying table, not table 33.1, in terms of the greatest, intermediate, and fewest number of reactions. If you look at the results, when you had them, you've got that in that table filled out correctly. It would be like this. So for zinc metal, you had a reaction every single time. For copper metal, you had a reaction 1 time out of 3. For lead, you had a reaction 2 times out of 3. So the zinc would be the most reactive, the lead would be the intermediate reactive, and the copper would be the least reactive, okay? So that's what was supposed to go there. And that's all you need to do for that table. And your reactions, just looking at the table that accompanied this, anytime, depending upon whether it was below it or above the different individual ones, said whether it would replace it or not. And that really was the whole point of this one. Okay? Metals with higher reactivity, higher on the accompanying table, replace metals with a lower reactivity below that item on the table. And that's not the table down below here. It's the table that was as a separate attachment to this. Okay? And then finally, the other one, there's a bit of issues with that one as well. So when I saw the lab 11, okay, most of you did the first 2 rows correctly. Well, this right here I gave you. And then from this one right here, you calculated the molecular weights. Yes, and that's true. This one right here, the number of moles, is just this quantity divided by this one to give you this number of moles. Now the equivalents, you have one equivalent of this, one of this, to form one of these, right? This is a balanced equation as it stands. Okay, but you've got an excess. There's an excess of this right here. So the theoretical yield is based upon the material that's in the smallest quantity. This is the limiting reactant. The limiting reactant determines how much is theoretically possible. So what you would do is you would take this number of moles times this molecular weight of this final product to tell you what the potential, the theoretical yield would be, right? So it's this number right here times this number right here to give you 2.609 grams. Many of you had vastly, vastly different numbers than this here. And this right here, if it's in excess, this doesn't enter into the equation at all. Well, it doesn't enter into the rate determining equation at all. And if this is the actual yield and this is the theoretical yield, the actual divided by theoretical times 100% gives you a 74.7% yield. Okay? And it's the same way with the next one. When you are looking at that one. Again, here you've got a different molecular weight because here you're making the methyl salicylate, right? The oil of wintergreen. This again is in excess. You've got 0.75 moles of this. You've only got 0.04996 here. Okay? Okay, and this right here, based upon this weight and this molecular weight, you only have 0.04272 here. So it would be this number of moles times this molecular weight would give you this for the theoretical yield. Okay, that's your theoretical yield. Your actual, yeah, I gave that to you. But then your actual divided by theoretical times 100% gives you 85.6%. Okay, so don't be surprised if you see something along these lines on the test, because this is something that you should have remembered from the earlier chapters of how you do this type of a calculation. Remember, whatever is the smallest number of moles on the reactant side is the limiting reactant. That determines how much you can possibly get as a theoretical yield for the product. And it's the product molecular weight times the moles of the rate limiting reactant, this type of equation right here, that tell you how much the theoretical yield would be. Okay? So I hope that's all clear now. And if you have any questions at all, don't hesitate to give me a call or send me an email. I'd be happy to help you out. And good luck on your exam on next Monday.